Hello! In this video, we will be conducting a temperature test on our Habitat Screen's retention insert. Before we begin trying to understand how the insert reacts to extreme cold and warm temperatures, we'll need to understand how they react in optimal room temperature conditions, which for the purpose of this experiment was set to 20 degrees Celsius or 68 degrees Fahrenheit. To conduct and record these changes in temperature, we'll be using a gap measure which is calibrated to 1 millimeter or 0.04 inches, as well as an infrared thermometer to record surface temperatures. In these experiments, we'll be using 4 test specimens. 2 of them are of an edge retention insert, the other 2 are comprised of a Pro Guide rail with the retention system installed within it. The difference lies in their length. The first 2 are 48 inches, while the other 2 are 10 feet, or 120 inches. Let's begin with measuring these specimens at various points while at room temperature. We'll first take a surface temperature to confirm that each of them measures roughly 20 degrees Celsius or 68 degrees Fahrenheit. Now that we've confirmed the surface temperature, we'll measure the gap in the edge retention for each specimen in 3 different locations. Upon doing so, we observed that the gap remained relatively consistent throughout, with a maximum fluctuation of 0.1 to 0.2 millimeters. Now let's jump into some of those extreme tests. We'll first have a look at a cold test. For this experiment, we set the freezer temperature to -5 degrees Celsius or 23 degrees Fahrenheit and left the specimens inside for an hour. After the hour, the surface temperature of the specimen read -19 degrees Celsius or -2.2 degrees Fahrenheit. For specimen 1, the edge retention insert, location A and C, read a gap of 1.1 millimeters or 0.04 inches, while location B read a gap of 1.2 millimeters or 0.05 inches. Test specimen number 2, the Pro Rail with the insert inside read 0.9 millimeters or 0.03 inches for location A and 1 millimeter or 0.04 inches for location B and C. All specimens remained rigid and operated as intended. From this, we've been able to determine that colder temperatures do not change the gap between the insert enough to affect the screen's operation. This means the screen has the appropriate channel to function just as smoothly as it does when in room temperatures. The second temperature test will explore extreme heat and how high temperatures affect the edge retention. For this test, specimens 1 through 4 have all been placed in an industrial oven at 60 degrees Celsius or 140 degrees Fahrenheit for 1 hour. After the hour concluded, we proceeded to take surface temperatures and found that each specimen averaged 55 degrees Celsius or approximately 131 degrees Fahrenheit. We then proceeded to check the gap measurements of each specimen, and the results were quite surprising. For specimen 1, location measured 1.3 millimeters, B measured 1.2 millimeters, and C measured 1 millimeter precisely. For specimen 2, which had the insert in the rail, the gap measurement stayed consistent at all 3 spots, measuring 1 millimeter or 0.04 inches. Specimen 3 and 4 also saw similar results, with a maximum fluctuation of 0.1 to 0.2 millimeters. All specimens appeared slightly more flexible, but operated smoothly despite being exposed to industrial oven temperatures for long periods of time. The conclusions drawn from this experiment? We've observed minimal fluctuations in gap measurements when each specimen was exposed to both cold and hot temperatures, and were able to run the screen through each specimen successfully after the experiment, ultimately illustrating the durability of our screen components in extreme climates. Thank you for watching. For questions regarding the product and its features, don't hesitate to contact us directly.